today several examples of simple circuits to indicate the phase sequence of a three-phase voltage, or phase order, or phase direction, or phase cessation. And this is especially useful when you want to connect a three-phase motor which is supposed to turn in a certain direction. But if the three phases are connected wrong, the three-phase induction motor will turn the wrong induction motor. Sometimes you can use error, and as a trial you just wire it randomly, and if it's turning the wrong way you just swap three phases. But sometimes this could damage induction motor, so the phase direction has to be tested. And there are several simple circuits to do this. The simplest one is to use three induction lamps connected to two phases, and the center point is connected to the third one via either a capacitor or an inductor. Then based on the direction, one lights up a dimmer and one dimmer. The voltage doesn't completely cancel out on three of them, so it's still dimly lit, but the other one is much dimmer. And it's using either a capacitor or an induction motor for the phase shift. But of course sometimes you have to use pairs of series induction motors instead of just one in each leg because of the high voltage. And the indicator is a bit cumbersome with relatively large tungsten motors and a capacitor, or some maybe some demonstration for completeness. One is way dimmer. Let's also try it with an inductor. It should be the other way. It is. And when I swap two phases, it again should be the other way. And it is. But for continuous operation you'd have to use a series pair of lamps for each, because the dimmer one is getting more than its nominal voltage. That's the capacitor and the inductor and the induction motor. But for it not to fail in several seconds you'd have to actually use two lamps, 4 and 2, even more cumbersome. So it might be more practical to use a neon lamp or neon lamps and just small components like resistors and a small and no inductors. Making an inductor for this purpose is possible, because at low current is barely 1 milliamp for the 9 lamps, and relatively low voltage in mains and high frequency 50 or 60 Hz, the inductor would have to have millions of turns. The inductance would have to be so high it's absolutely practical. This is one of the well-known indicators of a sequence with a neon lamp. It uses two CR circuits, basically two series combinations of a capacitor and a resistor. These are phase shifters. And the neon lamp lights up in one direction and in the other. And it's because in one direction the voltage between this point and this point basically is 0, and in the other direction the voltage between these 2 points is 0, and so the lamp lights up. And there is an even simpler version which uses one capacitor. There is one active divider and one phase shifter. And because this side is made of just induction motors, you don't have to have an additional resistor in series with normal, like in this one, where without the resistor there will be a direct path through just from one phase via the lamp to the other, which would make the noise lamp run in sudden pulses, which would make the lamp pulse. I will try to explain how these circuits work. I was thinking about the most way of explaining it without any complex calculations, and I came up with this. It's basically a phasor diagram and a schematic in one. And the distance between the terminals of the components is proportional to the voltage on the core, and the components are also drawn at a voltage proportional to the angle of the angle on them. This is probably not how it's explained in schools, but what I like about it is that you just look at it and get it. And of course the voltage on the capacitor is 3 degrees shifted against the voltage on an induction motor, so there's basically a right angle here and a right angle here. And if the values of the components are right, these 2 points basically meet. The voltage here cancels out and there is no voltage between them, and if you connect them all between them, it does light up. If they're rotating the other way, it will be basically flipped.